Okay, in this section, we're looking at number 3 on 9.5, and I chose number 3 just because number 1 was already in a nice, pretty format, but this one wasn't, so I thought I would do one where you had to do a little more work. If you look at the way the equations look on page 428 in your book, you can see, oh, this is supposed to be a 0 over here, I miscopied it. You can see that over here where I have a 0, I should have a 1, and I don't have it, so how am I going to get it? Well, how I get a 1 there is to take the constant term, this plus 25 on the left-hand side, and we'll just move it over there to get a number over there. Okay, so that would cancel out. And what I have now is x squared minus 25y squared is equal to negative 25. I still don't have a 1 there, but now I can get it, because what I'm going to do to get a 1 there is divide by negative 25, because any number divided by itself is 1. So this is going to become 1 here. But if I divided this by negative 25, I have to divide everything by negative 25. Okay? Now, if we simplify this, we can see that we got a 1 over here. This x squared over negative 25 is going to be negative. So what I'm going to do, I'm going to write that negative as a subtraction sign right here. I'm going to put minus x squared over 25. Now, negative 25 goes into negative 25 one time, and negative 25 goes into negative 25 one time. So on our y squared term, it ends up being a positive 1y squared. And since it's the positive term, I'm going to write it first. And normally I wouldn't write y squared over 1, but I'm going to do it here because I think it's going to help our brains pick up on what we need to do. Okay, so now I have this equation, and I can start answering the questions they want us to. And I'll start with the oral exercises, and then we'll go in, if you notice the way the assignment goes, oral exercise 3, you do it, and then on written exercise, you go back and look at number 3. So we're just going to do them all at the oral and written exercise on number 3 all at once, so that we don't have to kind of come back to it later. Okay, so for the oral exercise part, they wanted the intercepts of the hyperbola, which are basically, in this case, notice that you don't have a parentheses with your y or your x with something subtracted from them and the square on the outside. So in this case, my center is 0, 0. Because my center is 0, 0, when I count my a and my b over, just like I did with my ellipse, I'm going to do the same thing here. When I count over, they're going to end up as x and y intercepts. So one way I could find those points, if they want the intercepts, I could do what we normally do with an x-intercept, and that's to plug in y is 0. Let's go ahead and do that. If I plug in y is 0, I get 0 squared over 1, or just 0 squared, because that's just going to be 0, right? Minus x squared over 25 is equal to 1. And so we get, if I look at that, I could make this a proportion to solve. If I put a 1 over 1 and I cross multiply it, I'd get 25 times 1 is 25. And then 1 times x squared is negative x squared. Now this is kind of a problem here because I've got this negative term here. But if you think about it, you know that 5 and negative 5 squared is 25. Those are actually going to be your intercepts. This is why I don't like this method they're kind of taking you on here, because this is weird. We think, well, that's an imaginary number. But here's what the deal is. Since our center is 0, 0, our x-intercept, if we just go underneath the x, and we say, well, this is normally, remember back in ellipses, the bigger number was your a? Well, in hyperbolas, what's different is the positive number over here is your a squared, and this number is going to be my b squared. And so if b squared is 25, b is plus or minus 5, that's going to be plus or minus 5, 0. That's going to be on my x-axis, and it's going to be what we used to call it our covertices when we were with ellipses, but you know what, let's just go ahead and call it that here. I don't know that we need to worry about the names of that. Because the math here, plugging in 0, doesn't make much sense, does it, with the minus sign there. So we'll just say, you know what, that's why normally I've never taught this using x and y intercepts, because first of all, it only works with 0, 0, but also you run into problems with the algebra when you get to hyperbolas. So now those are actually going to be, though, they are actually going to be your x-intercept. So this is your x-intercept here. Now your y-intercept is just going to be the square root of the number under the y. If you noticed that happened with the ellipsis before, and really, because our center is at 0, 0, it's happening here again. So my y-intercepts, remember that's where x is 0, are going to be plus or minus the square root of 1, because if you say a squared is 1 and you square root both sides, you say a is plus or minus 1. Now if I were trying to find it by saying, oh, well that's going to be a y-intercept, and again, that's only happening here because we have a center at 0, 0. If we moved it off center, it would not be an intercept. But we could find it by setting x equal to 0. So let's just show that. Y squared over 1 minus 0 squared over 25 is equal to 1. But 0 squared over 25 is just 0. So you get y squared over 1 is equal to 1. And I'll make 1 a fraction by sticking it over 1. And if I cross multiply, y squared times 1 is y squared. And 1 times 1 is 1. And if I square root both sides, I get y equal plus or minus 1. This whole idea of x-intercepts and y-intercepts being how we graph a hyperbola only works if it's got a center at 0, 0. Otherwise, what we do is we go find the center and we graph it, and then we just say, well, a is plus or minus 1, b is plus or minus 5, and we count that amount out on each axis from the center. Okay, regardless, we have our intercepts here. So we now know that a is 1 and b is 5. 1 and b is 5. And why do I care? Well, they ask us to find the focus. Well, the focus is, there's an equation for that, and again, your book doesn't solve for c, but I'm just going to go ahead and do it. It's c squared is a squared plus b squared, which actually looks a lot like the Pythagorean theorem. Actually, that is the same letters and stuff we use for the Pythagorean theorem. Let's just plug this in. A squared is 1, and b squared is 25. And so c squared is 26. And what's your focus? If you square root both sides, your c value is plus or minus the square root of 26. Now the focus is going to be in the same on the same axis as your A was. And remember, that's called in the hyperbola, instead of calling that our major axis, for some reason they call it the transverse axis, which kind of always confuses people, but you can kind of think of them as the same thing. So it's going to be on the transverse axis, and the transverse axis is the term that's going to end up being positive. And in this equation, the positive term ended up being the y term. So this is going to be on my y-axis. And since the center is 0, 0, that means x is 0, and then our c value would go here, plus or minus square root of 26. So we got our focus. All right. If you look at the written exercises now, we've completed what they ask us to do. Oh, tell on which of the coordinate axes this foci lie. I just said it. I didn't write it down, though. It lies on the y-axis because the y term was positive, and the focus is always on the axis where the term is positive, called the transverse axis, which is like the major axis. Let me call this the transverse axis just here so you may remember it better. Okay? Now, the part down on the bottom, the written exercise like this. So let me go ahead and pull up a graph. Okay? Now, we know that our y-axis is our transverse axis. Y is transverse axis. And we know that you're going to count up 1. You know that A is 1. That goes on the y-axis. And you know that your B is 5. That goes on the x-axis. I'm just going to put that here just so we don't forget it. And we know our foci are 0 plus or minus square root of 26. I'll put an F in front of that so that we'll remember that's the foci. Now, how do you graph this thing? Well, remember we said our center was 0, 0. So I'm going to graph in red. Here's 0, 0. Since y is the transverse axis and the number underneath it was 1, square root of 1 was 1, so I'm going to count 1 up this way, just like I did with an ellipse, and 1 down this way. So you look at first like you're going to graph an ellipse. And since under the x squared term we had 25, the square root of 25 was 5, on the x-axis we'll count out to 5 one direction and to 5 the other direction. Now, instead of connecting them and making them ellipse, there's a few more steps here. And actually, I realized I did not give the equation of the asymptotes yet, so I'll do that in a minute when I get to it. Usually I wouldn't do that at the beginning, but that's what the book has you doing on the oral exercises. What you do here is you make like a box out of these points. So I'm making a horizontal line on the y-axis, and I'm going to make vertical lines, and you're going through those points that you graphed. Okay, see how I made a box, and I extended the lines for a reason. Now, let me draw the points now in a different color just so we can see where they are. Here, 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 and here, right? Okay. Now, we said that since the y is the transverse axis, this thing's going to open up or down. So here's what I do with this box. I connect the corners of the box itself. I should do that in a different color. This and this. The diagonals, I connect them in a straight line, and I actually go through the center to do it. Likewise, on the corners here, I go through the center again. Let's see if I can actually do this, sort of, okay? And if this thing opens up and down, I'm going to graph in blue now so that we can see the graph. You say, okay, here is a vertex point, and it goes and it approaches this asymptote but never touches it. On this side, those purple lines we drew from the diagonal of the boxes are asymptotes. Here's the other vertex, since it opens up or down, and again, this approaches that asymptote on this side and this asymptote on this side. And we've graphed it now. So you actually make a box, connect the diagonals, and since we know it opens up or down, we just go to that point that's on the transverse or major axis, and we make it approach the asymptotes. This is a perfectly fine graph for this. The one thing I haven't answered from the oral exercise is what's the equation of the asymptotes? Now, your book gives you a way to do this without counting it. You can actually count it off you could count it off the graph if you wanted to, but your asymptotes on an equation where you have a positive y squared term, which is what we had here, is y equal a over bx, actually, and y equal negative a over bx. It's basically plus or minus a over bx. So for my asymptotes, a is 1, b is 5, so y equal 1/5 x is one asymptote, and then y equal negative, a is 1, b is 5, negative 1/5 x is another asymptote. Sometimes we would actually write that as plus or minus 1/5 x. That's the way some books would write it. I'll go ahead and just do this separately since they didn't put it that way in your book. So we got our asymptotes, and let's see. And we found the foci already in the first part. So we've done everything they've asked now on this problem.